Hello everyone, welcome back. In this video, we will learn how to find permutations of n objects comprising R1 identical objects, R2 identical objects, and then so on until K. Okay, so this is the example of some repeated objects, which is n factorial will be divided with every of R identical objects. So let's have a look at what does it mean by identical objects. At the question 10 here, example 10, how many different permutations can be made using the letters of the word books? So let's start with the word books. B-O-O-K-S. So again, I use the boxes. It's easier for me to understand because there are 5 letters. So if there are 5 letters, we know that this is actually n equals to 5. But do we know what is the R? Yeah, we do not know yet. But let's learn first. So first of all, we must know that in the first digit here, it could be B or O or O, K or S. So 5 letters can be at the first digit there. So 5 there. And then if you cut one of it, tinggallah 4. If you cut one of it, tinggallah 3. If you cut one of it, tinggallah 2, tinggallah 1. So when you times all of them together, it will give you 5 factorial, isn't it? 5 factorial ataupun 5p5. So all these things you understand it perfectly already. Cumanya jawapan kita bukanlah 5p5 sekarang. Our answer is no more 5p5 sahaja. Our answer is actually 5p5 divided. Ini yang dipanggilkan kita perlu cari the identical object. So R is identical object now. So you got to see what is the same alphabets here. So the same alphabet here is OO. So OO has 2 alphabets, so we put 2 factorial down there. And so the answer is 5 factorial divided by 2 factorial. Let's use the calculator. 5 factorial divided with 2 factorial. The answer is 60 ways. Ta-da! That is how easy you're trying to solve the R identical object. It's just that many of my students, they kind of forget to divide every of the possible identical object. Sometimes we forgot, isn't it? So let's try the second question, mathematics. So maybe I give you another technique of different technique a bit here. I didn't use the boxes anymore, but I write this one. M mathematics. Mathematics. Why do I write it like this? It is just because I want to see the identical object is M, the identical object is S, the identical object is T. So you can see now there are 3 identical objects very clearly. So yang di belakang ni tak ada identical object. And so I just find out what is my N first. My N is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my N is 11. Then my R is how many? I got 3. This is 1, 2, 3. 3 different alphabets have a 2 identical object. So the way we write our answer is actually 11 factorial divided by 2 factorial times. Yang ini yang kita jangan lupa, times with the 2 factorial and times with another 2 factorial. So this is the answer. So use the calculator 11 factorial divided with 2 factorial times with 2 factorial times with 2 factorial. The answer is 4,989,400 ways. Wow, this is 4 million ways. But we do not want to use it. We do not want to calculate it manually, isn't it? Kita tak nak kira secara manual sampai 4 juta kali. Nope, we refuse to do that. And so that is why permutation, the knowledge of permutation came in. Okay, so just remember that we got to divide every possible alphabet if there is same identical object. We're done here. Let's go to the question 12. So question 12 here, how many different 10 letter codes can be made using 3 A's, 4 B's, and 3 C's? So here we can keluarkan dulu maklumat. We have 10 letters, and then we have A got 3, B got 4. Maybe I should use big letter. A letter got 3, B letter got 4, and C letter got 3 also. And so we know that the answer is very, very obvious. It is 10 factorial. Okay, remember that 10 factorial is the total factorial. Total must be at the numerator part. And then we must be divided with the three similar A, okay, I use A as the green color, times with the B is, I use red color, and then times with the C is the orange color. So basically these are the identical. C is the identical, B is the identical alphabet, A is the identical alphabet. So when it is identical, we must divide with its bilangan identical tersebut supaya kita dapat the possible ways of arranging 10 letters. So the answer is 4,200 ways of arranging 10 letters code.